Are you Bormik? Bormik Shulka?
Yeah.
Shukla? Okay. And whereabouts are you from?
Sorry.
Whereabouts have you come here from? What country do you live in?
India.
So you're from India, and what company do you work at?
Esri.
Esri. Okay, excellent. Fantastic. And then do you know the science? Yeah, so you've got 45 minutes or is it? Yep. So you know that, so I'll hold that up. Now we need 5 minutes at the end for route change. Yeah, so you want question and answers?
Yeah.
Do you have time allocated?
Maybe.
We'll see how we go. All right.
काम कर रहा है सिंपल आगे बंद कर ले फुल स्क्रीन पे दिखता है सारा
Are you ready
I think so.
at half past to go out and start yelling jungle and external authentication and herd?
Yeah. I'll bring this with me. Spruik it to everybody.
Oh, but this does not speak outside.
Oh, okay. I have to bring the speakers as well. Yeah, we'll need to get started then.
13, 15. Thank you. So, where to start? Why doesn't it want to? So it's not verbs. It's not showing verbs.
Okay, welcome everybody. This afternoon, our session is with Jan Paziota. Jan is from the Czech Republic and works for Red Hat, and the talk will be on external authentication for Django projects. Please welcome Jan.
Hello. Do I I need to do anything about the mic?
No, that's
Probably not. Okay, so thanks for being interested in authentication. Here's the situation. You have an application that you've developed, and a large organization is interested in it. And they would like to either buy it or deploy it, and you are excited about it. And the thing is, you've probably built it around Django contrib auth or something like that, and maybe you've extended it a little bit, and maybe you've added a nice management interface. But the organization wants all employees, all associates to have access to that application. And perhaps not just the employees of that application, but they have partners and suppliers and maybe customers, and all of their people should have access to it. The workflow, the ideal workflow is like this. A new person joins the company. HR is a good HR, and they put the person into their central identity management system, Active Directory possibly. They put the person into groups that somehow match what the person is supposed to do, or groups to which the person belongs. And when the person then finally gets their password and logs in, they should be able to log in to any service that is somehow related to the work that they do. So if you hire a new finance person, that person should be able to log in to their finance, accounting, or whatever application right away. If you hire a new network administrator, again, they should get their laptop set up, log into a domain, perhaps it's a Windows laptop, and then access their network management system, network administration, and be allowed to log in. And vice versa, the finance people should not have access to the networking management, and the network administrators should probably not be able to access the tax records. The problem is that no one will enter those users into application in large organizations. So when a new person is hired, that application somehow needs to learn about that new person and about their access rights right away. None of those administrators is going to type that person's details into multiple of their applications. They only want to do it once. Moreover, different organizations have different ideas and different requirements about what authentication protocols are to be used. Sometimes it's Kerberos, typically if you have Active Directory. Sometimes it's some chip cards. Sometimes it's SAML, especially when you want to integrate with other companies. Sometimes, often, the organization has a verified, audited method of setting up those authentication mechanisms using some front-end HTTP servers. And they won't change it for your application. They have standard that they want used. So I'll probably do it the reverse way I typically do it. I'll do a demo first so that you know what I'm talking about, and if you think that it's too easy, you can leave and won't suffer here. So I have FreeIPA server, which is basically something like Active Directory just on Linux, and I have Bob account created here. And I have a very simple Django application. The application looks like this. It just shows who is logged in, and it shows the last login attempts. So we are currently not logged in, only admin has ever logged in. That's the situation. And I also have identity provider, which provides me with SAML assertions. and it's connected to that free IPA. So I have 3 machines. Bob currently only exists in that free IPA server. Now, I can do it 2 ways. I can either click login here in that application, or I can click login here in that central single sign-on solution. Which way do you prefer it? Okay, so please log in. I'm Bob. I know the password. I get logged in. Welcome, Bob. Now, when I come to that application, I'm currently not logged in. I click login. I got redirected to that identity provider. I get redirected back. The log now shows that at 12:35, it's GMT time, so it somehow matches the reality. Bob has logged in. And not just that, Bob has acquired some privileges in Django. Now, well, either say wow or leave, because that's pretty cool. At the end, I'll show you the same with Kerberos, and at the end, you will be able to pick your own login so that you know that I'm not faking it. So how do we do it? I will assume that we have Apache, that Django is running under Apache, and that we want it to consume that typical standard remote user authentication result, right? So how do you do it? Well, since Django 1.1, you have remote user middleware. So that's easy, right? You set it up. Well, there are at least 2 problems. First, remote user middleware really expects all URLs or accesses to be authenticated. So even if, as the result of that access, and what I did not show you, and I probably should, if I look, I have 2 different Firefoxes running. So if I refresh the view, you can see that Bob account got created. And actually, it's not just know that it's Bob, we also know his first and last name. So there's more than just to the login name. But remote user middleware wants that login name to be present in that remote user variable or header, whatever you call it, upon every request. So you would either need to maintain some sessions in Apache, which is kind of duplicating what Django does anyway, because Django created a session, right, for us. Or you would need to re-authenticate upon every access. That might have been fine when HT password files and basic authentication was used. It's not fine if you use Kerberos, because you don't want to renegotiate upon every request. You don't want to renegotiate upon every, renegotiate SAML. Second problem is, if you use the standard auth views login, it does not really understand when the user has already authenticated via some middleware. It still shows that login page, even if the Django authentication session has already been created. What's the solution? Well, or how do we want it to work? We want external authentication, the one that the organization requires, be it Kerberos or JSS API in general, be it SSL, being SAML. I'll show some example with mod auth melon. We want it to be only created or only enabled on one login URL. The URL that we were clicking here. Let me log out from single sign-on, otherwise I will not be able to log out here. This is the login I'm talking about. For some reason, it does not show the URL, but it's /login. So the solution to the first problem is coming in Django 1.9. We have new authentication middleware called persistent remote user middleware, and it basically does what it says. It will only require that remote user external authentication to be present when the Django authenticated session is created, or when the Django session is marked as authenticated. And it will basically preserve it until you log out in Django. For the second problem, I've come with a solution which basically I'm seeking some comments about. If we check that user is authenticated, but unfortunately we need to write our own view or login. And of course, it can inherit from the standard auth views, but if we check that the user is authenticated, we just redirect to whatever the landing page of that login page is. So if the user if we click the login page and the user happened to be authenticated before the handler got a chance to be invoked because some middleware kicked in and found that remote user populated, we'll just say, well, okay, you are authenticated, fine. Django upstream is not currently very happy about this being the default, and so at the end of the presentation there will be more links about how we want to solve the problem. Maybe even is that a problem at all. Now, if you have a modern application, that username, that login, is not enough. Applications want to send notifications to their people, to their users. So they need some reasonable email address. Applications want to show welcome David when David logs in and welcome Bob when Bob logs in. So they want some additional attributes about the user. So here's the proposal. Since we started with the remote user for the login, let's use remote user and underscore attribute for attributes of that user. We've actually done that in other non-Django, non-Python projects, and it seems to work pretty well. If you are using SSSD-based installations, you can use mod lookup identity Apache module to configure basically mapping of LDAP or other attributes to those environment variables. If you use mod melon for SAML, you can do the same. So it's possible with, if we are depending on external, maybe Apache, maybe Nginx in the future, maybe some other front-end server, but if we are depending on external authentication, we should also somehow expect that that external environment, that front-end HTTP server, is able to populate some other environment variables or headers, whatever you call it, than just remote user. How do we consume those attributes in Django? Well, I have remote user attr middleware, which basically checks that the user, as we see authenticated in Django, is the one matching in the header so that there's no mismatch. And then it just uses those attributes, sets the attribute, uses those environment variables or meta values, sets attributes for user and saves. I would have pointed with a pointer if I had a pointer. So what this means is that upon every request, not just remote user middleware creates the user, which is what would happen normally. Because you need that user record created in your application database, otherwise your foreign keys won't match. or won't have anything to point to. But we will refresh that user record whenever authenticated session is started. So we have fresh data about the user. By the way, feel free to raise your hand and ask at any time when you don't like something, or when you're confused, or when you want to add something. Now, that's nice, but I said that we also want user membership to somehow relate to permissions that the person has in that application. So the networking people, network admins, will be put by DHR to some groups, which will make them have more privileges in the networking application than the normal people. And it's not a bullying thing. It's not like you either get in or you're completely out, because, for example, helpdesk people, you often want them to have access to everything but read-only, so that they can check status of things. If it's, for example, my background is system and network administration, so if I have IT helpdesk, they need to be able to see into things. They should not be able to modify anything, or only a few things maybe. So based on their group membership in Active Directory or somewhere else, they should be given application-specific permissions. The similar way, if I log in back as Bob, the similar way Bob got his 3 permissions here. So here's the proposal. Since we don't want to tweak the Django schema too much, we could have added special model, special database table to somehow hold the mapping. But let's start small. Proposal. If a group in Django starts with X con, whenever a externally authenticated user logs in, populate his or her membership in those X prefixed groups with whatever groups you find coming with that user. And vice versa. If the person is in that X prefixed group and no longer you see them being member of that group when they're authenticated, remove them. So that when the person changes departments or is no longer working on the project, you have one central place to do that setting, and it gets propagated to any application which gets hooked to the central server via similar mechanism. At the same time, if the administrator admins need to say that, yes, this person, even if they are not network administrator person, they will need to have certain permissions. They can use any other non-X prefixed groups and manage their permissions any way they like. I'm just proposing that those X prefixed groups are somehow special, and yes.
You're assuming that you only have a single external authentication mechanism. I think you want to namespace this in order to be able to have multiple ones.
That's actually a very good point. One way, I'll show in a minute, I'll show a code that does it. So one possibility is to have separate spotted a problem. I did not want to get that deep in this talk, so you are ahead. So we said that we would have, that we could have remote user email for email. So why not have remote user group for groups? And the way you can set it up in mod lookup identity, which does lookups using SSSD, which is an OS level authentication and identity solution. And the way it is possible in mod auth melon in the coming version that I hope will be released soon, is that it populates group _n so that you know how many groups are coming, and then you have those individual variables with separate names. Another possibility would be to have it just colon separated in one value. That's also a possible way to do it. And then we have the middleware, and yes, the prefix is somehow hard-coded here. Because I thought that we need to start small and start somehow. And then we look at the groups that we get, we look at the groups that we currently have, and we basically update what we have, and then call this and save the user and update the user. So I showed you how it can work with SAML. Let me do it with Kerberos. Let me log out so that we have somehow a vanilla state. What user would you like me to create? Come on, say something. Well, you'll be very silent. Annie or Penny? Penny, okay. Let me give her a password. Let me try to make this smaller so that you can see more. Yes, it works, cool. And I will not just create the account. Oh, I've been speaking too long, so I need to re-authenticate as administrator, which would be much easier if I saw the bottom of the page. Okay, so we have Penny created, and let's put Penny into network admins group because she's joined the IT department. So we just created Penny. Let's change email address. Where do we have email addresses here? So that you can trust me that it's not just faking it. So we have Penny created. Sorry. We have Penny created. Let's kin it as Penny and Kerberos likes realms. By default, FreeIPA creates the users with the password expired, so I had to change the password. But I have a ticket granting ticket for those of you who are fluent in Kerberos, which basically means it's a good thing. So let's verify what we have in the Django application. We still only have admin and Bob. And now, well, now I need to change the configuration of that application because, let me see, where has it? HTTPD conf. I have Epsilon, which is the client for SAML here. So let's remove that. I could have used both, but I don't want to complicate things. And Django external configuration, let's put it here. Conf d. Restart Apache. And so I'm logged in, single signed on. This is what you would see. You would see a TGT if you logged in on your Windows machine as well. Let's click login. Now we can see that Penny has logged in, even if she did not have any account there. If I refresh now, the account is there. I can see that her email address is there, all right. And I can check that Penny is a member of X network admins group. So her group membership that I created, that I set up in FreeIPA, got propagated. And if I look at that network admins group that I had pre-created, you can see that it has listed these 4 randomly picked just for the purpose of this presentation permissions. And if I look at what the application says to Penny, it lists just exactly these 4 permissions. Conclusion. It is possible to support multiple authentication mechanisms without writing Python code. Now, this is a Python conference, so you might not find that a good thing. But first, it might be required that a front-end authentication should be used because it's what the company or government body uses. And that implementation might actually be much harder than you can imagine if you start from scratch. In Django 1.9, it is possible to easily use authentication enabled, that external authentication enabled in Apache or in another front-end server, just for the login URL. And it will survive with that persistent remote user middleware. You need to be careful, especially if you want that login page to still be available when the external authentication fails. Because you might want users to use Kerberos, but fall back if they don't have a ticket. And by the way, just so that you trust me that Kerberos happened, you can see the HTTP service ticket was created. So it really was Kerberos that authenticated Penny. Now, yes, traditionally, remote user was what authenticated users. And in Django, we had the functionality to create that user automatically upon the first login for some time. But these days, you probably want more than that. Attributes of that user, and yes, you need to find a way to somehow match what you have in your corporate identity management to what attributes each and every application adds to the model. And more importantly, group membership, because you can link permissions to groups and have those permissions pre-created and predefined, and when the user gets created, they get propagated, and you can use them. Again, we were not writing a lot of Python code. We were not writing SAML or Kerberos in Python. We are just consuming external authentication. Depending on your view, it's either a good thing or bad thing. So I welcome your questions and comments. And here are some links to go with this presentation. And now really, ask me some questions. Yes, please. Actually,
Sorry, do you mind just repeating the question?
What about federated logout?
The identity, well, first it's hard. Second, the Epsilon identity provider does support it, and SAML does support it, but depending on the protocol you use, it's either possible or not. So if you are thinking about a kill switch, if the person gets fired so that they're really logged out, I don't think that you'll find a solution, like a standard solution. So I was not focusing on that.
Would you be using the same method if you were using OAuth or something like that for login?
Possibly yes. Epsilon supports it. I'm not sure how groups would work, whether you could use it for authorization, you know, the ending part, getting groups propagated. But yes, that's... The question is how much or how often you will find it used for end users within organizations. To me, it's more for public access. The gentleman in the back.
My question is actually pretty similar. I thought about more OpenID Connect. So when I already have a single sign-on based, for example, on OpenID Connect and anything else, do I depend on the implementation on Django that it's possible to connect it, or how does it work? Because you were talking a lot about Kerberos or SAML. So what is really necessary that I'm able to connect my single sign-on?
Well, my answer would be, what does your Apache support? Because I'm really trying to not do it in Django. I'm trying to build a framework is a bad word, but I'm trying to find an approach in Django which would make it possible to use what maybe other languages and frameworks use. So if it's implemented for Apache or for some other front-end web server, then you should be able to consume it this way without having direct support for it or direct knowledge about that protocol in Django itself. Yes, but at the end of the day, you get authenticated user and some attributes. So all I'm saying is, don't try to, or maybe you don't want to try to address it in Django. Maybe you want to find existing solution for that and just consume the result. And it does not really matter how many round trips the protocol mandates to get the user authenticated. Eventually, you will get the remote user or the indication that the user has authenticated, and that's what we use here.
Hi.
Hello.
We actually used to work together. I'm wondering if you have ever made like a similar Django app, but with like UWSGI or something else other than Apache.
With what?
With UWSGI or some other server other than like Apache.
Well, we actually had a person working on the module on the modules for Nginx. So we're trying to somehow expand the approach to non-Apache, but we are still only focusing on Apache as our main thing. And again, it would be about implementing those protocols in those additional servers. And then consuming the result in, hopefully, a standard way. Okay, so thank you.
Everyone, please thank Jan. Sorry, my alarm went off. I hope it didn't throw you off. That was excellent. So we've got 9 minutes.
We have 9 minutes.
Yeah, so if you just want to get set up.
Yeah, sure.
Yes, but you're really approaching it from top down. You're moving it away from Django itself. Yes. Down to WG. And all I'm saying is, why not use what you guys did? And start at the very bottom where everything starts. Because then you can use it for non-Django application or non-Python application. The reality is that there are those.
Another thing, if I remember correctly, what Django is missing is logout method per backend. You have a logout view which logouts the Django bits, the reverses, the sessions, and so on. But if you had a logout per backend, then you could have all the logic there that is for systems that are capable of logging out as someone is. And do the right thing.
Yes, but if you're only talking, or if you're only thinking about web, which is what this is about, then that logout will go through the web, so you can cache it in the same way you caught it during logging, you will cache it during logout as well. And well, to me, the backend is really not the backend, because the backend gets assigned to the user whenever they log in. It's not a attribute of a user. It's mostly an attribute of the session.
Usually there's several ways of logging at the same time. We use some example often with both the OpenID plus IDA. Sometimes you do not go to the external site to log out, you log out internally from the Django app. And what we do, at least when we use SQL in PHP, is that we log out locally, and then we ask for the external root. And will you just log out from this one, or log out from everything? If I need to be nice, if you're already working on
Okay, no, do you,
So if I
just in
understand
terms
correctly,
of the timing, how long is your talk?
Well, it's scheduled to be 30
30
minutes, and I should talk about 20 minutes and then 10 minutes for questions.
Okay, that's fine. So I think, is there a
you
talk
have a
coming
way
up
to
after you?
redirect.
I think it's the last one,
after
actually.
Okay, because otherwise we do need to allow 5 for changeover.
Seems
But
pretty
because I think it's the correct
straightforward.
place to put it.
Do you have a ticket number for that?
Nope, but I submit one.
Yes, that'd be awesome. And
this one here, speeding up search. Is
That's right, yeah.
that it?
Then you will also
That's it?
That's it,
the
perfect.
last
So it's the last one. I can overrun horribly and it'll be fine. Except
Everyone, I love you for it. And how do I pronounce your name?
Maciej.
Maciej.
Maciej Kula. Yep.
Maciej Kula. All right,
Perfect,
fantastic. Where
thank
are you
you.
from? UK?
I live in the UK, I'm actually Polish. So
Okay, and what company do you work for?
I work for List. LYST, yeah.
Okay, perfect. All right.
Cool.
So let me just get that right again. Marseille.
Maciej.
Maciej.
Yeah.
Okay.
Tricky names are tricky.
I might not need another pointer.
If you mangle it, that'll be
Maciej.
perfectly fine.
Thank you.
Yeah. 5 minutes.
5 minutes to go. From Azoy. Excellent. All right. So I'll just hold these up as we count down. So when you've got 10 minutes left,
Okay.
and when you've got 5 minutes left, I'll just hold them up. place the cell holder.
Make it 3 minutes and
Exactly right.
try to complete it in a span.
Okay, welcome everybody to Python for Cloud Services and Infrastructure. This is being presented by Balmik Shukla from Azoy. Please make Balmik welcome.
Hello everyone. Am I audible, right? Okay. So here I'm talking about Python for cloud services and infrastructure. Let me tell you something about myself. I'm Balmik. I came from India. I have around 5 years of development experience. I'm a open source savvy guy. I love Python. I do some DevOps and site reliability things, but my core will be the cloud. So let me tell you my current product and little bit about it. So we have developed a smartphone case which can read your body vital when you place finger on the case like this, and it will read your BP, ECG, heart rate, skin temperature, SpO2, and it will show those things on your mobile and sync it with the cloud. So I worked on the cloud part. Yeah, so this talk is all about cloud and the internal components. So yeah, to build any web application or any cloud services, we have these questions first, like from where to start, which tools we can use, how to integrate stuff, and things needs to be taken care of. So from this presentation, you will get all these answers maybe. So yeah, so I'll let you know the Python friendly stack that I've been using since 3+ years and which is very reliable. So of course, any application, any web application or any cloud service will have this kind of stack, this kind of set of components you need to prepare, where there will be some web framework, WSGS server, task queue, database, login, caching, and many other things. Yeah. We also need to take care about other components like this. So we'll discuss all these things later on. So start with where to start. The first thing will be the web framework. Let's finalize the first web framework. What kind of web framework we are going to use. When it comes to the Python, we have 2 famous framework available, which is Django and Flask. Django is like fully armed and fully included things inside Django. But Flask, well, it's a kind of a small framework which is very extensible. So you can attach other things with this Flask. So these 2 are most famous. I always prefer Django because it has a few things included, like authentication is there, so you don't need to worry about all of the things. Yeah, so how to run our web application. So we need WSGS server, WSGI server. Okay, so what kind of WSGI server we need? It basically gets the what WSGI server does. It gets the data from the upper layer and process that data inside the process and generate one output, which can be a response, and send it back to the request. If it is a request response thing. So we have two good WSGI server available in Python. These two are most famous. So one is G-Unicorn and one is Micro WSGI or UWSGI. I generally prefer UWSGI because it has much more configuration power. There is no specific reason to, you can choose any of them. So yeah, we should have some WSGI server. Next question will be database. So what kind of database we need? I mean, either it's a SQL database or no SQL database. It's based on our use case. So if we have some data elements which we need to be relational, so we need some sort of SQL database, SQL database. So these are a few databases that we can go for. PostgreSQL is there, MySQL is there, and MongoDB for NoSQL. So currently in that product, in that cloud, we use MongoDB for the 90% of the transactions. So NoSQL you can use for if you have some unstructured data. So yeah, that's the thing. Next is web server. So any client, any requests will not directly communicate to the WSGI server. It will pass through the web server. So web server will take care of all the requests. It handled it and pass it to the WSGI server. WSGI server will process it and return back the response. So this is the general architecture we need to figure out. These two are most in use web server. Actually, these two takes 50% of internet traffic right now, combinedly. So yeah, either you can go for Apache or you can go for Nginx. Nginx mostly known for speed, and Apache mostly has some configuration power. So based on your use cases, you need to define your web server. Yeah, this is very interesting. Next is the task queue. So when you want to perform some ad hoc tasks, like on some request, like if you are creating one account, one create account request comes, and you want to generate some newsletter or some email things, or that can be done in a distributed way. So you should have a task queue which can perform all these things. So if you write your task queue, it's good, but we should not write our own task queue because it's already there, which can solve few problems like queuing, like a retry mechanism. For example, there is one task came to send one email to a customer, which has been, which just registered himself on our website. So if there is something failure happen, we should have some mechanism to retry that. So that is one. Some timeout, some scheduling, or some status of the task, maybe. So that can be solved by some existing task queues. Salary is most famous there. Redis queue is there. I always prefer Salary because it has a good dashboard as well, and it has a good monitoring of tasks. So yeah, you can go for Salary. So next is logging. So logging can be event-based, or the full logging feature could be you can log everything or some specific. So I always prefer Sentry over there because Sentry has uh, a good logging power as well. Plus, it provides one good dashboard where you can search your data, event-based data, and all the events you can monitor it from it. It also provides notification. Uh, when you configure your event, like if any error occurs, you should get an email. So that can be done by the Sentry. CloudWatch is another option. So you can go for it. Yeah, you also need to take care about other components, as I said, like source control. It's a must thing. I think everybody does this. So yeah, specific version, if I want to check out some specific version, so source control will do it, all things. Uh, it also provides good history and accountability, remote accessibility. So yeah, these two are most famous source control system. One is Git and SVN. We use Git there. So deployment and configurations. So these two are most important thing out of after the development. When you want to check out a repository in the cloud and remotely access the server and execute some SSH, execute some commands through SSH, or maybe that can be done. So few uh, things are there, like Fabric we use. It has a good SSH based remotely accessibility, and Ansible, Chef, Puppet can be used for configurations management. And deployment could be automated, not manually, like we should not do that. So Jenkins is there. Jenkins will do all the automatic deployment initiation. After getting deployed all the things, we should keep our eyes on process and system and activities. So we need to monitor system, like how many nodes are there in our server system and cloud. Each server has their health, and we need to monitor all those things. For that purpose, we use Nagios. Nagios provide a very good monitoring platform where we can monitor all the system as well as processes. When I say processes, it means there can be UWS SDI processes, I mean UWSG processes, or Nginx is there, so we can monitor Nginx from the Nagios, or MongoDB server is running well or not. So that can be monitored through Nagios. Sentry is a kind of monitoring service where we always monitor our logs. If any error occurred, if any unusual thing happened, then we can directly be notified by an email. So Sentry is a good kind of monitoring service there. It's basically a logging system, but it provides some kind of monitoring. Supervisor is there. So supervisor will do and control your processes. You can start, you can stop from that dashboard. So you can allocate something, and you can configure by your use case. So supervisor is also there. So yeah, cache is also one part of our cloud where we need to have some cache mechanism based on our use case. If we are serving static content on a website, then we should have some front-end cache. And if we are serving some content, not the static content, but some content which can be reusable or frequently asked, so some caching mechanism we can implement by Redis or Memcache D. We use Redis there. So yeah. Messaging. So in messaging, I would like to share one use case where messaging can help. maybe you have multiple app servers or multiple DB servers, or let's take an example of app servers. For example, 3 app servers are there. If one app server is doing some task and wants to notify others that I have done this task, now you can start. So at that time, messaging can be useful. We use RMQ, RabbitMQ, many people say, which provides some pub-sub mechanism, public and publisher and subscriber, where subscriber can join and subscribe to the server, and it will be notified when if we publish something on the channel. So yeah, it can. So it is the messaging. That's it. Yeah, virtual anyway. So I love this feature because it provides one isolated Python environment in your system, because you can have n number of Python environment in your system, and you if you are working on a different project, you always have a different dependencies. So virtual env will help there. You can create one environment, you can install the dependencies, like I need some dependency of version 1.0, and in another project you need some dependency of 1.1. So it will be isolated for each of them. So yeah, it's really great feature. Analytics, yeah, you always like to see your users' data, or how your users are using your website, maybe your application, your clients are using your things. So analytics can be done by either you can use Google Analytics for the static page, where JavaScript can send data to the cloud and it will show you on the dashboard, or you can use internal analytics, where you can build your own dashboard. So there are few tools available, like Graphite is there, StatsD is there, which can send all the metrics to the cloud, and Graphite will arrange it into the graph. Yeah, few other things we need to take care of is scaling. It depends on your use case, what kind of usage you have. You may have a database overload, so you can scale your database vertically or horizontally. You can have a performance-based scaling, where your system, your application, number of applications are not sufficient, so you may scale those applications and servers. You may have periodic backup of your data, which can be done through Jenkins and Fabric jobs, or that you need to figure out how you can do it. So, and yeah, replication and periodic backups may provide data reliability. So your data always be there if you have set up all those things then. And load balancing is there, where through Nginx or through Apache you can kind of balance your load. Yeah, that's it. Any questions? Yeah. Thank you.
Right. Thank you, Balmi. You will. Thank you. I don't know. Good question.
perfect, thank you. Lovely. Just, you know.
So I saw you list guys roaming around. It's a fashion site.
A fashion site, exactly. Very fashion. Well, we ourselves, I wouldn't speak for anyone, but most of us aren't really fashionable. But
Yeah, perfect. Speeding up search for locality sensitive fashion.
precisely.
Is that XFCE?
It is XFC. It's very temperamental, but might run. Oh, it did run. Great.
So just talking about the algorithm or an implementation in
Mostly about the algorithm. So I'm going to talk about the algorithm first and explain to you how it works.
Yeah, yeah. Did you say you invented the algorithm?
I have an implementation, but I don't invent the algorithm.
Okay.
So this is like a well-known algorithm for doing near searches.
Okay.
So I'm going to walk through the information behind how it works and then list a couple of Python implementations.
Perfect. All right.
Give a rationale of why you want to use it in the first place.
Yeah.
Hopefully that'll work.
Oh, look, we'll see how we go.
It is the last talk.
You got the last slot. Australia, actually.
Like, you got base in Australia.
Yeah, so
So you flew all...
Oh yeah,
very
go
impressive.
EuroPython. Yeah,
Oh, very nice.
Well, my wife's going to join me tomorrow actually. We used it as a bit of an excuse to kick up a nice European holiday.
That sounds nice.
Yeah, so anyway, it's been really good here. I enjoyed it.
Where are you going? Are you just staying in Spain?
Well, we're going to go down to, we're going to walk the Camino for a week.
Say again, sir?
Do you know the Camino?
No, what's
To
that?
Santiago.
Right,
Compostela?
the
Yeah,
pilgrimage trail.
Yeah, so we're going to do 1 week of that, and then we're going to go in a caravan or camper van from Barcelona up through the south of France, then to Paris, then to Switzerland,
In renting a
Vienna,
camper van.
home. Not the whole, just for the south of France. Yeah.
That sounds
I've
very
never
nice.
done it before, but yeah, it's going to be exciting.
That sounds
Except for driving on the other side of the road, but not sure about that.
I don't think it's true. Driving on that?
We drive like British.
Yeah.
Yeah.
So the right side of the road.
Yeah, the right side.
The right side. Oh, that's very good.
Now that camera is fixed, so no cartwheels around the stage.
Okay, I'll try to
They
keep...
can't keep up with you if you do that.
I will try. I tend to move around a lot.
You're pretty hyped up by locality sensitivity.
More by the stress of public speaking. But yeah.
How are we going for time? Oh, we're ages.
When do we start?
We
In
have
10 minutes.
So, what have you learned that's new and exciting at EuroPython?
I'm actually a very bad person. I didn't get leave from Leicester Fashion Company to get here
Oh,
early,
really?
so I just arrived last night.
Oh my goodness!
Only
Wow.
today,
Yeah.
Yeah, but it's fairly interesting. So there was a talk by a guy from Yelp and, about microservices, which is interesting for us because we're sort of moving into this microservice direction.
Yeah. Okay.
And we already have some growing pains, and it was
Yeah.
interesting.
Oh, was that the one about the adolescent?
Yeah,
Yeah.
going out of
Yeah.
the teething pains of microservices.
Wow. Okay.
So that was interesting. Yeah.
So is the idea of microservices that it's container-based implementation of, like, does it imply infrastructure or just the fact that it's RESTful separation of concerns, tiny little things?
I think it's well, I'm not an expert. I think it's mostly about separation of concerns, and it doesn't have to be containers. Or you can run a bespoke service.
Yeah,
It's still a microservice.
Yeah,
I think
okay.
we're doing it the container way.
Yeah. That seems to be kind of coupled to an implementation detail, right?
It is an implementation detail, but it's
Yeah.
sort of nice because you push your containers and they magically appear. Although, of course, I hate Docker. Well, I don't hate Docker.
Yeah.
But it's temperamental.
Yeah. I haven't used it, but I did see, like, FreeBSD had jails forever and a day before it was fashionable.
Exactly.
And then Docker comes along and it's like, hey, look at this. But lightweight places
you go to the keynote this morning?
Yes, but I got there about halfway through.
Okay, okay.
But that was interesting.
But the presenter was saying as well, it's like, well, Docker got there and said, we have this new amazing thing, and we at Google thought we're going to be doing this for a while, but you know, we're getting the bandwagon and say,
Yeah, that's exactly right. It's crazy, isn't it? Well, that's software fashion, right?
software fashion, yeah. It works. We use it everywhere. It's,
Yeah. Hello.
what you should really do is go up there and get some more people into this room.
Rustle them up, Kalan.
I bet Hamas room was full.
Huh?
I bet Hamas room was full.
It was full, yeah. So you jealous?
A little bit.
A little bit. It was very full, yeah.
Some friend of ours from this was just saying in the pipeline. Just finished.
Okay.
So what do you do in Australia?
Web development. So a lot of stuff is applying it. So I was coming back into the dark ages.
Remind me of how it is.
So it's like a content management system.
Right.
Yeah. So it's been around for ages. It's a booth out there. So yeah.
Because I was seeing references to it in the run up to Europe. I think what's Flow, and then there's like a journal, like biology or physics journal called PLOS One, and I thought, is that related?
Oh, it probably could be. I mean, there's a lot of. Might not be actually.
Probably not. It's like an academic journal.
Yeah. Okay. No, so Plone is. I mean, it's used by a lot of kind of everybody, but it's hierarchical object-based persistence mechanism.
Right.
Before that was trendy, so it's all just Python objects that get serialized into a thing called the ZODD.
Okay.
So object database, hierarchical storage of stuff, role-based access control.
So is it more like Django or more like just SQL?
No, like neither. So the whole idea is you don't have a object relational mapper. So you're not trying to shoehorn non-relational hierarchical data into a relational data structure. Okay. Yeah, it's interesting. It's got its pros and cons. It's not good for like write-intensive workloads, but it's really good for intranets and document management systems. Anything where you need to say, boom, you know, these people, ACLs, those sorts of things.
Okay.
So yeah, keeps us busy.
How are we doing in time?
We've got 3 minutes.
3 minutes.
I'll answer all your phone questions in 3 minutes.
3 minutes.
But it's been interesting being here and seeing some of. So you were at a pyramid.
Pyramid.
Yeah.
I heard of it today for the first time.
So Pyramid's like a
I
web application framework that sort of grew out of the sort of framework that Plone is written in, is a thing called Zope. And
I remember that.
that's like the original Python web framework, and some people say the original object publishing framework. So it's like 1999. So Pyramid takes a lot of the ideas that were in that and then modernises it. And that seems to be the new, not the new hotness. I mean, it's been out for 7 years now, but people are finally catching on. There's some pretty interesting.
I should look into it.
Yeah, definitely.
I'm sort of a Django shop, and I don't really come from like web developer background. So
Yeah.
for me, Django is the thing that
The
you do.
go-to, yeah, well, that's exactly right. Everyone's using it.
But I should really look into it more.
Cool beans. There you go. A few more people.
Yeah, perfect. My vanity is gratified. I'll walk around.
So there's a few minutes for questions at the end.
I think so. I should be wrapping up within 20 minutes.
Cool,
If
okay.
any.
Yeah, so I'll work on the basis of 10 minutes. You sound like you got it nailed anyway. I'll hold these things up.
Thank you.
No problemo.
People have questions, you probably want to see that. Okay.
I'll just introduce you so I might get you that out there. Come in, don't be shy. How much is it? Okay, everyone. Welcome to Speeding Up Search with Locality Sensitive Hashing. It's being presented by Maciej Kula. Maciej is based in the UK and works for List. Please make him very welcome.
Hello, I'm Maciej, and I'm a data scientist at List. We're a fashion company. We basically go all around the internet and we get all sorts of fashion products from all sorts of retailers and all sorts of designers, put them all in one place so that as a user you can just go to one website and follow your favorite designers and browse all your favorite fashion products and buy them from us. So that's the principle. And I'm going to be talking about nearest neighbor search. So nearest neighbor search is very simple in principle. Basically, you have a point, and you want to find other points that are close to it. So the most obvious applications is obviously maps. So that's something we use every day. You've got, let's say, your location on a map, and you want to ask Google or Bing or whoever you want to ask, what are the nearest restaurants to me, or what are the nearest cafes, and that's what it does. It figures out where you are, or you give it the location, and then it looks up other points on the map that are the restaurants that you're looking for, and then calculates the distances between where you are and when the restaurant is, and tries to give you the closest ones. So that's basically the essence of nearest neighbor search. Given a point, give me other points that are close to it. Now, this is the most obvious application, but even if you're not building a mapping application, which you may well not be building, we certainly aren't, you may still find it very useful. So what do we use it for? Well, we use it for image search, and we use it for recommendations. So, image search, how does it work? The principle of image search is, well, you've got an image. Let's say we had a user, and they submit an image to us of a dress, and they want us to give them images of similar dresses, or something that's a good substitute for the dress that they've submitted to us. So, as programmers, it's sort of hard to find similar images just by looking at an image. So the first step you want to do is to transform an image into something that you can more easily work with. So one very naive idea would be to, let's say, well, we've got an image which is RGB, like red, green, and blue, and these are 3 numbers, and for a given image, we could average the values of each color, and then try to find other images in our database which have sort of similar color values. And that's a very naive approach, and it's definitely not going to work. But it illustrates the principle that after transforming the image into a numerical representation, you've got a point. In this case, you've got a point in a 3D space, and that's nearest neighbor search. If you want to find similar images to the image the user has just given us, we look up other images, other points which are close in that space. So that is nearest neighbor search. The way we would actually do it is something more complicated. So recently, the most fashionable way of doing this, and probably the most effective, is deep learning. So this is a very simplified diagram of a convolutional neural network. So basically, the black square, the far left end of the slide is the image that you start with. And then you basically build a machine learning model which successively detects more and more interesting features of a given image. So let's say at first you detect just simple edges. Is there a line in that part of the image that goes from left to right? That sort of stuff. But then as you progressively build better and better representations, you start to learn more and more about an image. So maybe in the first layer, you just detect edges. In the second layer, you detect shapes. Is it a square? Is it a circle? And in the following layers, you detect higher and higher level concept. Is it a cat, or is it a dog, or is it a building, or is it a bridge? Now, the nice thing about it is that in the final layers, you've got a long list of numbers, an ordered list of numbers, a vector, which represents a point in space, in a high-dimensional space. And the nice thing about it is, well, the images of cats in that space are going to be close to other images of cats, and the images of bridges will be close to other images of bridges. So that's how you can do very good image search. And this is indeed what we do at LIST. We sort of take images and process them into this point representation, high-dimensional space, and then we want to use nearest neighbor searches to find similar images. That's useful for two things. Like, one thing is search. You give us an image, and we can find you similar images. Or maybe you type in a text phrase, and then we convert your text phrase into a point in the same high-dimensional space where the images are, and suddenly we can find images which are similar to the text you typed. So that's really cool, and that's something we can do. Other useful applications, the duplication. So we've got two images, and we have no metadata associated with those images. But we know that these are the same products. Like, the underlying truth is this is the same product, and we can use this nearest neighbor search to find out that these are the same products and present them just as a single thing rather than two disparate things on a website. So that's really useful. Another application is recommendations. So this approach is known as the sort of collaborative filtering approach. So basically, you have your products and you have your users, and you represent both products and users as point in space. So let's say we take our products, and this is a handful of points, and we cast them at random into this high-dimensional space. And we do the same for users. These are our users, and we represent them as points, and we cast these points at random into a high-dimensional space. And then what we do is, well, if a given user, i.e. a point in our space, interacted with a given product, we draw the points together. But if a given user did not interact with a given product, we push them further apart. And the nice thing about it is, at the end of this pushing apart and pulling together process, users end up close to the points, to the products that they will like, and far apart from the things that they wouldn't like. So when we want to recommend things to a user, well, we look up the point that represents them in the high-dimensional space, and then we use nearest neighbor search to find the products that they would like. So that's also very, very useful. So I'm a data scientist, and data scientists are very excited by these sort of things, and we spend a lot of time thinking about them and implementing them, and you sort of go away and you work for 6 months, and you come up with this amazing solution where you translate pictures of products into this high-dimensional space where similar products are close in space, and you say, well, as a data scientist, I've done this amazing thing, and it now works, and it's going to be great. Let's just deploy it on the website and make lots and lots of money, or make our users really, really happy. Now, this is where you are as a data scientist. You've got your beautiful child, which is going to be great, and you sort of go and let's just deploy it, let's make it work. So how would you do it, right? You are given a query point, or you take a user and you want to find all the nearest products, and that's simple, right? You go to your database and you find all the points representing products, and you compute the distance between your query point and all the points, all the products in the database, and you just order that and you give the closest ones. Simple, right? I mean, it couldn't be simpler. So yes, but no. The problem is, at least, we have 80 million images, and we have about 9 million products. So if we wanted to do the simple solution, i.e., calculate distances with all the points, and then return the closest, our users would be very, very bored by the time we finished. It would take literally minutes. So that will not work. Okay, so how do we make it work? Locality-sensitive hashing to the rescue. So we all know about hash tables, or dictionaries in Python. So we're going to build a special hash table. So we're going to pick a hash function, which, unlike normal hash functions, it maps points that are close together in space to the same hash code, which is very different than normal hash functions, which are supposed to map things uniformly over the hash space. So this is sort of special. It picks 2 points that are close together in your space, will map to the same hash code. And you just build a hash table, a normal hash table using that. So you take your points and you take the hash codes, and then you put your points in the hash buckets corresponding to your hash codes. And then magically, all your points that are close together will end up in the same bucket. And when you're doing search, you just look up the bucket that you need, and you just search within that bucket, which is really nice. So to do this, at list, we use random projection forest, and I'm going to tell you how that works. So this is our imaginary space of points. So we've got about 100 gray points and one blue point, which is the query point, the point that we want to find the nearest neighbors for. And this is how we do it. So if we didn't do locality-sensitive hashing, we would have to calculate the distance between the blue point and every other point, which takes too long. We cannot do that. So to make it faster, we draw a random line. That's the beauty of it. We just take a random line and draw it. It has to go through the origin, but otherwise any line will do. And the nice thing about it is, well, if we look at the picture, most of the points that are closer to the query point end up on the same side of the line. And the points that are not close to the query point end up on the other side of the line. So just by drawing a random line, we managed to create two hash buckets, and we only have to look through half of our points to find nearest neighbors. So that's already, a speed up factor of 2, just with one random line. And, we didn't have to do anything intelligent to draw that line. It's just a random line. So that's the nice thing about it. If this speed up is not enough for you, you draw another random line. Again, completely random, and the points that end up on the same side of the line end up in the same hash bucket. If this, again, the speed up is not enough for you, you keep drawing lines until you've got few enough points in your hash bucket. And that's your speed up, right? So you draw enough lines to have small enough hash buckets, and then when you need to perform a nearest neighbors query, you take a blue point and you calculate which hash bucket it should end up in, and then just compute brute force distances between the query point and the points that are in the same hash bucket. So that's the principle. If you can think of it as building a binary tree as well. So we start with all the points, and then we have a split, and the points that are on the left side of the line go into the left subtree, the points on the right side of the line go into the right subtree. And then we follow the right subtree in this example and do another split into a left subtree and right subtree, and another split and another split. And you can, sort of with a query point, you can start the root of the tree and then follow the splits until you end up in the right hash bucket. So that's the principle of how it works. Now, it works really, really well in some cases, but in some cases it doesn't really work very well. So the way we started this, at least, we thought, well, we're going to draw a fixed number of these lines. And hopefully that will give us a speed up, and hopefully will be accurate enough. So what we did is we decided on a dimensionality. Let's say we want to do 100 random splits, and then after 100 random splits we stop, and then things that end up in the same bucket are the nearest neighbors, and the rest we discard. That works reasonably well if your points are fairly uniformly distributed in your space, right? Because all regions are of fairly equal density. Wherever you draw the lines, your hash buckets are going to end up of roughly the same size, so the same number of points, and the splits are going to be good enough. But in spaces where some regions, in problems where some regions of your space are of high density, but other regions are of low density, what you're going to end up is with buckets, some buckets having lots and lots of points, and some buckets being completely empty, neither of which is very good. So if you have a bucket with lots and lots of points, you're not going to get a good speed up. If you have a bucket with very few points in it, you're not going to get any results back, both of which are horrible. So the first point is keep splitting until the nodes are small enough. So you don't take a fixed number of splits, you just build a binary tree, and you split, and you split, and you split until you've reached your stopping criterion, which is this bucket contains X number of points, and when that happens, you stop splitting, and you take that tree. So that's the first point. The second point is use median splits. So if you just take random hyperplanes, random lines, you can end up with highly unbalanced trees. So the left subtree will be very short because for some reason there are very few points there, but the right subtree will be very, very, very deep because there are lots of points in that part of the space. That's not really horrible, but it's not great either because you spend more time traversing the deep part of the tree, and you will
be traversing the deeper part of the tree more often because that's where more points are. So median splits. You take a random line and then you calculate the median distance from the point to that line, and then you split on that distance. So that it's guaranteed that half of the points will always go to the left tree, and half of the points will always go to the right subtree. So that gives you nice balanced trees and faster traversal times. And the final point is build a forest of trees. So you don't just build one tree, you build lots of trees. What's the reason for that? Well, the random projections algorithm and locality-sensitive hashing in general, these are approximate algorithms. They don't give you an exact answer. They're probabilistically correct, but in some cases they will be wrong. So if we look at this picture, if you look at the query point, well, maybe there are some points to the left of the line that are closer to the query point, to the points on the right side of the line. But if you build just one tree, we're never going to surface these points because they're in a different part of the tree. So that's a mistake that this algorithm makes. And that's not great. We want to have as good results as we can, given the speed up. So the way we get around this problem is we build lots of trees. And because in each tree, the lines are chosen at random again, each tree will make its own errors, but they will not repeat each other's errors. So when you combine the predictions from all the trees, they will end up correcting for each other, and the accuracy score of the aggregate will be higher than the accuracy score of any single tree. So that's why you build lots of trees. Then another nice property of this approach is if you build more trees, you're going to get more accurate results at the expense of, well, having to traverse more trees, so it's going to take slower. But this is something you can control. You can pick basically the trade-off between the number of trees you build, it draws you a performance curve, and you can pick a point on that performance curve, i.e. speed versus accuracy that's appropriate for your application. So that's very nice. If you want pure speed, build few trees. You get pure accuracy, but you'll be very quick. If you want something accurate, but don't care about speed that much, build lots of trees. It'll be accurate, maybe not so fast. Okay, so that's the principle of the algorithm. Does anybody have any questions at this point? Because I'm happy to clarify.
Obviously, it works well for two-dimensional points. How do you generalize it to higher dimensions? Like I assume you will use hyperplanes, right? But how do you split the feature space with a hyperplane?
Right. So the algorithm, actually one of the main reasons of the existence of the algorithm is high-dimensional spaces. And the reason why it's in 2D on the slides is because 2D is easy to visualize, and high-dimensional spaces aren't. So that's why it's in 2D. But basically what you do is, in the high dimensions, you draw a random hyperplane, which is whatever your dimensionality is, and then you do the same calculation. So it's exactly the same principle, which is just in higher dimensions. And it works very well for very high dimensions. We can talk about that afterwards as well. Okay, so that's the principle of the algorithm. How do you do it in Python? Since we're at a Python conference, it's sort of useful to give an idea of Python packages. So there are several Python packages for doing this. One of them is Annoy, which is a very cleverly named package, ANN, approximate nearest neighbors. Very cleverly named package from Spotify. It's very nice. It's a Python wrapper for C++ code. It's pip installable. It's very, very fast. It's actually very nice. Another package is LSH Forest, which is in scikit-learn. Those of you who are data scientists or play with ML, you probably already have scikit-learn on your computers, so it's really easy to use it because it's already there. And it's also quite easy to use. And then you've got Flan, which is, I believe, C++ code, and it's sort of gnarly and hard to deploy. The nice thing about it is you give it your data, and then it takes a long time to train, but it figures out the optimal structure for your problem, and that gives you high performance in the end. And there's a Python wrapper for it, which works, I'm told. There are some bits that we don't like as much. So LSH Forest itself isn't scikit-learn. You can read the source, it's fairly readable, but it's actually very slow. So if you want to develop for a high-performance application, maybe not the best solution. Flan is a pain to deploy. It's C++ code. You need to have CMake, all sorts of dependencies. Annoy is great. I recommend you use it. But for us, it didn't really fulfill two important requirements. One is it doesn't allow, once you build a forest of trees, you can't add any more points to it, which for us was a no-no. We need to add new products to the index as they come in. So this is something we needed. And secondly, you cannot do this out of core. You have to keep all the vectors in memory all the time. So yeah, so like any engineer, we wrote our own. It's called RP Forest, which speaks to the algorithm. It's available on GitHub, and it's pip installable as well. So please go forth and try it out and break it in all sorts of novel ways, and I'll try to fix them. It's quite fast. It's not as fast as Annoy, but it's fast enough for us. It's certainly much, much faster than LSH Forest, which is built into scikit-learn. Allows adding new items to the index, and does not require us to store all the points in memory, which is really, really very nice. So how do we use it? We use it in conjunction with PostgreSQL. So basically, we have a lightweight service that has the ANN indexes in it, the RP forests. So we send a query point there, and what it gives us back is, these are the product IDs, or these are the image IDs you are going to be interested in. So we get these IDs back, and then we push them to Postgres and go, dear Postgres, here are ID IDs, please apply the following business rules, so all the filtering, all your where statements, and so on and so forth, and then do final distance calculations also in Postgres using C extensions. So we store the actual point locations, the actual vectors, as arrays in Postgres, and we've written some C extensions to Postgres that allow us to do the distance calculations in Postgres, which is quite nice. Side note, Postgres is awesome. If you're doing all sorts of numerical stuff, you have arrays in Python, you have arrays in Postgres, and you can write custom functions to do anything you want in C. So if you really want to, you can write your stochastic gradient descent machine learning algorithms in Postgres and run them in Postgres. I'm not sure you should do that, but it's definitely possible. So the whole combination, the algorithm and the implementation and Postgres as a backing store, gives us a fast and reliable ANN service that we've deployed in production. Gives us approximately 100 times speed up with a 60% precision at 10. Means that if we get 10 nearest neighbors, we get the 6 out of 10 actual nearest neighbors using the approximate approach at 100 times speed up. So I think that's reasonably good. Speed up over brute force. Over brute force. Not particularly demanding speed up baseline, but that's where we start. So we've got that. It allows us, and the speed up that we gained, it allows us to serve real-time results. So we don't have to pre-compute, we can just serve it real-time, which is also very nice. And it's all built on top of a real database. So stuff like concurrency and updating the database, that's all taken care of by smarter people than us. So it works well. Anyway, thank you, and I'll be very happy to take any questions.
Yeah, hi. Now, I've just did something like that for chemistry with distance, and I'm doing brute force. But I would like to ask you for an estimate of what number of entries this is going to be hard. So when is my application going to need trees, like in the future? I don't know when.
I mean, it's sort of an empirical question, right? So it then depends on your requirements as well. So let's say if you're doing offline processing and you want to, you don't really mind that it's taking 10 seconds or 20 seconds with the data you have, that's fine. But when you, let's say one lookup takes 10 seconds, but you need to do your lookup 100,000 times, then maybe that's the point where you really want to look into these solutions. If it's fast, that's sort of, if it's fast enough for you, for what you're doing, you don't need it.
So what was your pain point in your application? What was too long for you?
So let's say if we want to serve web requests, like 100 milliseconds is too long for us. And doing this brute force would take anywhere up to 3 seconds, and it would completely destroy the database. So getting from 3 seconds to under 100 milliseconds, that was the difference for us.
Hello, and thanks. I have a question about clustering. So are there any algorithms like k-means and so on, which could be fast and precision, have nice precision? Thanks.
Yes, so the question is, can you use clustering algorithms to achieve the same sort of effect? And yes, you can, and there's an approach called hierarchical clustering, which again is sort of building let's say a binary tree, for example, where you have all your data points and you put them into two clusters, and you build two clusters, and then these are your two clusters on the first level of the tree, and then you go down into each cluster and you recursively build more clusters and keep splitting the tree. That's also an approach. It's not something I have investigated, so I cannot give you a good answer on what the performance trade-offs are. Okay.
No more questions?
Cool. Thank you.
Thank you much.
And we're all done.